Good morning, ladies and gentlemen. My name is Martina Hahnen. I'm with METOP and I'm really glad to present you our water-free cooling technology ILTEC and explain how to bypass problems related to water cooling. Very good morning from my side. Too bad we cannot see each other face to face. However, thank you for listening to my presentation. Before starting the presentation, let me just give you a short introduction of who we are, where we are, and what METOP is dealing with altogether. So METOP, we are a group of metallurgists located in Leoben in Austria. As you can see here, Pira Industries is part of our company. So you see here the two founders of METOP, Dr. Andreas and Dr. Iris Filzwieser. Also, we are shareholder of a copper casting company, Beco, located in Spain, and also of Urban Gold, which is responsible for the recycling technology and especially WEEE recycling. So you can see here our product portfolio. So as I said earlier, we are metallurgists, but our core technologies come from the non-ferrous industry with a special focus on copper technology. So we do have a lot of knowledge in non-ferrous metals units. We are also very intense in refractories in non-ferrous. Also, as I said, regarding the Urban Gold in e-waste recycling. In addition, we have a lot of know-how in our tank house technology. But the topic I would like to focus here today is regarding the ILTEC technology for cooling of metallurgical vessels. So everybody knows you need to have a good refractory lifetime. You need to cool, but also the problem is with the main cooling medium water, there might be severe safety issues. So therefore we invented a technology which bypasses the problems related to water cooling. So let me start with a short question. So is water dangerous? And as you can see here in this video, and this is just an exemplary video you can find on YouTube everywhere, water can be dangerous. If it comes in contact with liquid melt or slag, you see the 1700 volume increase just via the transition from liquid water to its gaseous form. So this reaction causes fatal accidents all over the world, all over our industry. So here it says it's 200 incidents that are reported over the past years, but this is just the reported numbers. So I'm quite sure there's a lot of more incidents. So as you can see, water is a dangerous medium, and therefore we want to try to redesign safety with our ILTEC technology. What you can see here in this illustration is a graph with likelihood and consequences of accidents that will and do occur. So we cannot really change the likelihood of any accident. So still when you have a cooling loop, there is the chance that liquid metal penetrates the cooling loop and there might be some accidents or incidents, but what we can really decrease is the consequence of some kind of accident. So you will see there is no explosion, no dangerous reaction with our cooling medium ILTEC. So what is this special medium all about? I do have it here in my hand, so you can see it here in a lab scale vessel. So an ionic liquid, our ELB 2001 is an ionic liquid, and per definition an ionic liquid is a salt. So you can see here it's a liquid salt. You saw it's liquid by room temperature. Its operating temperature starts from around 50 because of the viscosity, goes up to 230. So you have a quite wide range where you can use this cooling medium. And after 450 degrees, it's decomposed, so it's perfectly gone. Minimum operation temperature is -10, so you can also operate with it in very cold environment, maybe with some additional heating. But what is the real characteristics besides technical data, so it gives no explosive reaction when it comes in contact with any liquid, melt or metal. We have tested it in first lab scale, we have tested it in industrial scale at Montanwerke Brixleck and at Böder Edelstahl. So there is absolutely no explosive reaction. Also, important facts: it is not harmful, it is not toxic. Even when it's decomposed, the gaseous components will burn, but there's no toxic gas. It's also not corrosive, so there's a special chlorine-free composition of it. It's a patented operation, especially created from Proionic, which is also an Austrian company. It provides sufficient cooling. I will show you later some technical data. You do not see any altering effects or changing behavior. So even if it's in operation for years and years, you won't see any changes. And it's also not combustible, so it can be used as an hydraulic oil at some hydraulics. So here you see some more key facts and key data. As I said, the operation temperature is from 50 to 230. Short-term stability might even be a little higher, so it's 250, 260 or something, but still the liquid is fine with that. Absolutely minimum operation is -10, and at 450 it's completely decomposed. You can see here the density, so it's a little higher than water. You can also see here the specific heat capacity. And some of you will immediately say, oh, that's much lower than the specific heat capacity of water, which is around 4.2. And yes, you're right, it is lower. But however, if you see the equation here below, so the heat removal is always a product of the mass flow, the specific heat capacity, and also the delta in temperature. And when you see here about the operation temperature and the large range, yeah, you might have higher delta T, or you will have, so it's about double to 3 times, but still the heat that comes to the cooling medium, either if it's water or if it's ionic liquid, it can be perfectly removed. So there's no restriction in that. It's basically, you can say, when you can cool it with water, you could cool it with ILTEC and ELP 2001. So how does the hardware of such a cooling system look like? So it's more or less not rocket science. It's just a pump station with tank, heat exchangers, some measuring devices and valves. So you start here at a tank, you go via a pump for providing the flow throughout the system. The warm ionic liquid comes back to the system, comes to a heat exchanger and gives the heat to a secondary water cooling circuit. So basically you remove the water away from the furnace, away from the critical area, but you still need the water to recool the warm or hot ionic liquid. Here you see a picture of our reference plant as installed in Germany for many, many years. I think it's more than 6 years running by now. So this is the hardware. So now I told you some basic facts about our cooling technology, but the really interesting question is, what do I do with it now? Where can I use it, and where does it really make sense replacing the water? So the first main topic is to replace the water just in terms of safety. So whenever you have a cooling application, especially when you think of tap holes or critical parts at some sidewalls, you can just replace the water in the cooling panels with the ionic liquid. It will perfectly work the same way, and you have a more safe operation. But since we are metallurgists and also scientists, what's really interesting is how to create new cooling applications. So now, with a safe cooling medium, you can cool areas which was not possible or thinkable before. So you can think of underbath cooling at an electric arc furnace. You can go for cooling lenses submerged into a melt. You can think of converter zones cooling in copper industry, which is not possible right now. With these new cooling applications, you can even think of new processes. So you can really create vessels with a total underbath cooling for creating new processes. And last but not least, you can also have some heat recovery. Since the cooling medium is up to 230 degrees, there's really a lot of energy in it, and you can think of heat recovery in any of your systems. So since the title of my presentation is how to implement it in electric arc furnace and how to implement it in sidewall cooling, let's just give you a brief example of where to implement our technology in an electric arc furnace. So actually there's a lot possibilities. So thinking about cooling of the bottom shell, as I earlier explained, so bottom vessel is never cooled because of safety issues. So I will show you later, we do have a reference where we did cool the lower vessel, just increase the refractory lifetime tremendously. But you can also think of cooling the upper shell panel. So still there is a high danger for leaks, and also there you can have this water volume increase and give severe explosions and damage to either personal furnace or the whole surrounding. You can also think of siphon tapping cooling, or let's say lens and lens manipulators. We're in close contact now with a steel plant. They had an accident with their lens manipulator, so we are in close contact for how to implement the ILTEC technology there. You can also think of cooling the burner boxes, which is actually no problem. And also because of the high temperature of the cooling medium, you can also think of cooling off-gas ducts at a higher temperature level. So you don't need to cool down, let's say, to 50 degrees. So there you might have some dew point corrosion. And if you just cool it at a level of 200, you can prevent this dew point corrosion, which we have also done in a zinc oxide plant, where we prevented the sulfuric acid composition at the furnace sidewall. But you can also implement this at an electric arc furnace off-gas duct. So, but coming to the EAF sidewall cooling, let's start with if you remember the 4 columns, let's start with a new cooling application and cool the sidewall within the lower furnace shell. There are different possibilities of how to do so. Just let me start with a let's say plain plate cooler, which can be installed just behind the normal brick lining and the steel shell. So you introduce here copper plate coolers, which is then cooled from the outside with the ILTEC technology. So basically you can really prolong your lifetime of the furnace refractory material. You need to replace it more seldom, and you can really increase lifetime, you can increase productivity, you can decrease refractory costs. So this is really, on a cost-wise base, a nice application and a nice new cooling application. So you can see here, this was really installed at the steel plant some years ago. Here we replaced this, or let's say we just shortened the bricks at the back side and inserted this around 2 square meter of cooling panel. And what you could see at the end of the furnace journey, let's say, if you compare the brick layer size from this cooled area to the non-cooled area, you could really see an increase in thickness in refractory. So there was really still refractory bricks in front of this panel after the entire furnace, or let's say vessel journey. So this can really be implemented at hotspot areas. In this case, I just showed it was just right behind an electrode, so it was really a hotspot, and you could really increase the lifetime. If you would further go for a permanent vessel, let's say, if you don't want to replace your refractory from time to time, you can think of a more intense, cooler design. So you can see this is a so-called CFM cooler. It's a copper backplate with copper fingers where a castable refractory is filled in between, which has a very, very high heat flux, and you can really create a freeze lining in front, so you really freeze on some slag and some metal, and this permanently protects your furnace, so you can really have a permanent vessel design. This is actually quite common in the ferroalloy industry. You see here a very large furnace with these CFM cooling panels. In this case, they were water cooled, but for safety reason, definitely go not for water cooling, but to an ILTEC technology. So if you just summarize what cooling in the lower part of a vessel gives you as a benefit, so you can increase the safety, you can decrease the damage in case of any leakage. You have also a fast leak detection. So since our technology supervises each of the supply lines very closely by means of flow detection, pressure detection, temperature detection, you can really have fast leak detection. You can avoid the hydration of the refractory. So even in case something starts to leak and the ionic liquid is running into your furnace, is running behind your refractory, there is no hydration of the refractory. So the refractory is not going to be touched in any way. So still gives you more safety. You can have an easy and fast and safe repair work. So because there is no chance of water explosion, you can have a more access more rapidly, and still you can use the heat recovery. Actually, this was the benefits for the lower vessel, but basically it's the same also for the upper vessel. So all those benefits, more safety, fast leak detection, heat recovery, easy and safe repair work, no hydration, is the same also for the upper vessels. So therefore, let's just go on. So, I mean, you can use your upper furnace sidewall cooling just the way it is. So just replace the water with the ILTEC technology. It's perfectly fine. It's perfectly working. So you have a perfectly safe furnace. But also thinking one step ahead to create new and improved copper coolers, which you can see here. There's a copper pipe casted in the copper matrix, so there's no Monel or even steel pipes inside, which gives a much longer lifetime because of the same heat coefficients of the matrix and the copper pipe. So just not only to replace water as a cooling medium, so this is just for safety reasons. Also think of new cooling applications with the new and improved sidewall cooling panels. So because of the lack of time, my time is almost over, let me just end with the possibility of doing some pilot and industrial scale tests with our ILTEC test rig. So if you have one special part that's really highly stressed, you want to try out if the heat removal is okay, how the system is working, just give us a call and we can think of how to test at your furnace under your very conditions. I would be happy to. And last but not least, let me sum up in some bullet points what this new but proven cooling technology stands for. So you can increase the safety, you can think of new cooling applications, you can even think of new processes. Because of the high temperature, you can think of energy recovery. And finally, I just want to say, let's together think out of the box how to create a better and more safe environment at your furnace. Thank you very much for your attention, and I'm happy to answer all your questions or receiving an email or a call, just what you like. So have a nice conference. Bye. See you.